Today we're going to talk about melting point concepts and the procedure which you can use to measure melting point of some compounds. So, at first about the melting point. So the melting point of a solid compound is defined by the temperature at which the solid and the liquid phase coexist in equilibrium. In other words, melting point is the temperature at which the solid and its liquid have the same vapor pressure. Vapor pressure is the pressure exerted by a substance against the pressure of air. Both solid and liquid have vapor pressure. As temperature increases, intermolecular attractive forces are overcome by increased kinetic energy, leading to disordered liquid. But if we have any kind of impurity in our substance, the melting point will change. Melting point of a substance is usually expressed at the temperature range over which the solid starts to melt and then is completely converted to liquid. So rather than a melting point, a melting range is actually measured. Pure compounds show a sharp melting point range, usually just by 1 Celsius. If a pure compound is contaminated with some impurities, then two things happen. At first, melting point range becomes broad, less sharp, usually by 2 to 3 Celsius. Melting point, and the second is that melting point of this impure compound is usually lower than the pure compound. This is called melting point depression. So here we're going to talk about a concept named eutectic point. So as I mentioned, when we have an impurity in our substance, the melting point usually decreases. So for example, when we have a compound A, a pure A, the melting point, just assume that the melting point is A. And we have another compound B, a pure compound, which its melting point is B. So when we have, for example, a mixture of 80% A and 20% B, here B is impurity of our A compound. So the temperature C will be less than A. But when we have a mixture of 20% A, 80% B, the impurity here is A. And so the temperature, the melting point is lower than B, which is the melting point of pure B. So, but where is the eutectic point? The melting point of a mixture, for example, 60% A and 40% B here in our graph, is the lowest temperature, which the compound, the mixture, will be melted. So here, this point, E, will be called eutectic point. So for example, so for different mixture of different pure compounds, you need to find out the E point. For example, the eutectic mixture of ice and salt is 70% ice and 23% salt, and eutectic temperature is minus 21 Celsius. So, what about the procedure of your experiment? Which, however, for this semester your class is online, so you don't need to do any experiment, but you need to be familiar with the procedure. So, at first, you need to prepare a different mixture of benzoic acid and 2-naphthol. The first mixture will be a completely pure benzoic acid, and the second one will be 10% 2-naphthol, 90% benzoic acid. The third one will be 50% 2-naphthol and 50% benzoic acid, and the fourth one will be 90% 2-naphthol and 10% benzoic acid, and the last one will be pure 2-naphthol. So after preparing these 5 mixtures, you need some melting point capillary tubes. So melting point capillary tubes usually have one end closed end, closed end, and the other end will be open. So you need to press the open end of the melting point capillary tubes into powder, and by tapping the closed end on a hard surface, for example on the desk, you can gather the powder at the bottom of the capillary tube. After that, you need to use a Digimelt instrument to detect the starting temperature, starting point of melting, the initial temperature, and the end of the melting step. So, if you check uh, uh, the instrument during the heating step, when you saw the first drop of melting of your solid, so that's your initial temperature. That's the beginning of melting step. And during range by 2 to 3 Celsius, you will see that all of your powder will be converted to liquid. So that's your final temperature. So in this way, you will have a range of temperature, which is your melting point range. For that specific mixture, you have 5 different mixtures. So if you do the experiment, you will do this calculation and drawing this graph. However, you don't do the experiment, so you don't do this. You don't need to do this step. So, but you need to be familiar with this. So you need to draw the temperature versus percentage composition of 2-naphthalene, for example, to find the eutectic mixture, eutectic temperature. So you will have 2 lines, in fact. The first will be the melting begins, where the melting begins, the beginning temperature, and the second will be the, for example, here the red line will be the ending melting point, the final temperature. So in this way, you can find the eutectic mixture, which is the lowest temperature where the mixture will be melted completely. So you would have some solid waste, which you need to throw them away to the solid waste container, and the glass waste sharp container, which you will through your melting point capillary tubes to broken and used to the sharp container. And you need to, after doing your experiment, you need to turn off your digimelt approaches. So that's not for you. So good luck, guys. That's it for these experiments.